Being able to relate physical properties of matter to the attraction, um, that the mass and the shape of the molecules, individual molecules. So here you've been asked to rank the following molecules according to increasing boiling point, or the amount of energy that it takes to separate the particles. So if you were asked which particles would take the least amount of energy to separate, that's like saying which particles would take the least amount of energy to boil or separate them from being this close to that. That's pretty much what the question is asking, boiling it, going from liquid to a gas or pushing your particles apart. And if we look at the three molecules that we have in terms of particles, like here, we will see that this one would boil off the quickest because it's a smaller particle and it's round, so it won't really be able to get too close to the other ones to attract. And the fact that it's very small means it doesn't take a lot of energy to get it go flying very fast. Then we have, so this would have the lowest boiling point, or 1. And now we're explaining it, and we just explain why this is 1, or lowest boiling point. And then we have these two other options. This molecule looks much bigger than this one, and it's flat, which is attractive. We know that things that are flat tend to stick very well to each other. However, this is number 2, or would boil with second highest boiling point and not the highest because it doesn't have any permanent charge. We know that magnets stick to each other because they have positive and negative charge. So whenever things have a lot of colors on it, or molecules, especially dark blue and red, the darker the color, the more charge we have. Usually the blue will be negative and the red will be positive. So in this case, we see that this molecule has some permanent charges and this one doesn't. So this will attract a lot stronger, like a magnet, even though this is heavier. So the reason why this one has the highest boiling point is because the molecules have permanent charge. They're kind of flat and pretty decent size, but overall the charge wins hands down. So that makes it having the highest boiling point. So, and this one doesn't have the highest boiling point because it simply doesn't have any permanent charge or dipole moment. So here we have another question. Which molecule do you expect to form a compound as a gas at room temperature? And it would be propane, because again, molecules that have permanent charges either are going to be liquids, and if they're big enough, they can be solids. So these guys, um, this this one is closer to becoming a gas than this one, um, because it's smaller and it has less blue and red on it. So this one is out the question. So propane has no permanent charge, no blue or red electrostatic cloud or mapping on it. So it will definitely boil a lot faster, or it's very likely to be a gas at low temperature, like a room temperature. And if we go back here, gases have very low attraction. So low attraction means you're likely to have a gas, and if you don't have a charge, attraction is going to be low.